Okay, so now here we have end of Unit 1 assessment. We have some questions, so I don't know if we can see them. So we have some questions, end of unit assessment number 1. So probably end of Unit 1 assessment. So we have a list of questions. So I don't know if it is clear from this light. We have too much light here, but I hope this can be seen for sure, so that if one is watching the video, we can pause and see this list of questions. Number 1, number 2, number 3, number 4, number 5. Until there, I hope it is clear. I don't know what to position myself. This is the first 5 questions. We have another list of questions. Question number 5 is continued over here. Again, let us put some light. So sub-question C for number 5, then number 6, number 7, number 8, number 9. So we have these questions. It is still end of Unit 1 assessment questions. Don't know if it is clear. So that my student can pause the video and look at this, and then the list continues. So the next questions are these. If we put too much light, maybe it can be clear. And we have sub question B of question 9, and then number 10, the last 2 questions. So these are the questions that we can try to answer. Okay, so now let me just start by question number 1. Okay, so now this is end of Unit 1 questions. End of Unit 1 questions. Okay, so question number 1. Okay, let me just put it like this. I hope this will work. So question number 1. So it is end of Unit 1 assessment questions. End of Unit 1 assessment. Questions. End of Unit 1. End of Unit 1 assessment. Okay, so we have question number 1. I have 10 questions, as I have indicated. Okay, so now question number 1 is write down the order here should be placed by size of the following matrices. So we have A, matrix A, comprised 2 by 3 matrix, -3, 4, 2, 1, 5, -1. So second matrix is a 1 by 2 matrix, 4, negative 1. 4, negative 1. Okay. So now, so we are going to answer question by question. So this question, or maybe I can put the second one also. We are going to answer on the second question. Question number 2. Let me try another matter pen. Given that matrix A and matrix B are equal. Suppose that the two matrices are equal. Find the values of the parameters like M and K in the following question. So question A. So question A, we have it is A 3M plus 2, 2K plus 1, and B is equal to M minus 3, 2, 5, 6. So these two matrices are equal. And B, we have A is equal to x minus 1, x plus 4z, and negative 3, second column, 3y plus 4. So first matrix, second matrix, which is B, 2 by 2 matrix, 6x plus 5, 1, 2, 1. Okay. So, okay, these are the first two questions. So let us try to answer them right away. Okay. So we are going to answer of this end of unit 1 assessment. Okay. So now here, what is this matrix? So this matrix is, its size is 2 by 3 matrix. This is a 1 by 2 matrix. It means that this one has 2 rows and 3 columns, and this one has 1 row and 2 columns. So 2 rows and 1, 2, 3 columns. Okay, so that is the answer for sub question 1. So question 1 actually. Okay, so now what about second question? Okay, second question is given that matrix A and B are equal, what is the matrix? Okay, let me use this one. I hope it will be clear in the video. So that is A. So we are having, if it's a 2 by 2 matrix, coefficient at the same position are equal. So we have 3 for A, 3m plus 2 must be equal to m minus 3. And we also have 2k plus 1 must be equal to 5. if the two matrices are equal. It means that if A is equal to B, then we have this situation over here. So what will be the value of M? So you solve this question, this equation number 1. So you will find 2M is equal to -5. So it means can simplify 2M, then simplify here -5M, which means that the value of M is equal to -5/2. Okay, now how about the value of K? So we can solve to see that 2K is equal to 5 minus 1, which is 4. And then when we take 2K is equal to 4, which means that K is equal to 2. K is equal to 2, which is equal to 4 divided by 2. Okay, that is sub question A. How about sub question B? Sub question B. So we want also this matrix A to be equal to matrix B. So what does it mean? It means that x minus 1 is equal to 6x plus 5. 6x plus 5. Okay. So now, and then x plus 4z is equal to 1. And we have also so 3. So 3y plus 4 is equal to 1. Okay. So actually this is a system of 3 equations and 3 unknown, a linear system actually, because each equation is linear. So now what we have here, okay, let me use a black color. So this is the same as we can have group similar terms in order to get -5x is equal to 6 from the first equation here. From the second equation, we have value of z. Okay, let me just use this one in the first one. Z is equal to 1 minus x divided by 4. And what about y? Y is going to be equal to, from the third equation, it is equal to 1 minus 4 divided by 3. Now it is the same system as x. We can have it as -6/5, and the value of y is equal to -1. Why? Because -1, y is on the other side, -3 divided by 3 is -1, and then z is equal to 1 minus x divided by 4. And what is x? X is -6/5. So in this case, what is result? X is -6/5, y is -1, and z is, now we have +1 plus 6/5 is like 11/5. And now this is over 4 is 11/4/20. 5 times 4 is 20. Now these are value of z, and we can check. So let us check for this one. M equal to negative 5 over 2. It is negative times the negative 15 over 2. Negative 15 over 2 plus 2 is like negative 15 plus 4 over 2, which is negative 15. That is negative 15 divided by 2 plus 4. Okay, so this is negative 11 over 2. And I compare with this one, if they are the same. So it is negative m equal negative 5 over 2. I subtract 3 is like 6 over 2. So which will be negative 11 over 2. So which means that negative 11 over 2 here, same as negative 11 over 2 here. So this quantity and that quantity are the same, which means m is correctly equal to negative 5 over 2. Okay, how about checking the velocity of 5 being equal to 2k plus 1. So if k is equal to 2, of course 2 times 2 is 4 plus 1 is equal to 4 plus 1, which is 5, and this quantity is the same as 5. So for A, checking is okay. So we have good values of m here and good value of k. Okay, checking for values of x. So if x is equal to negative 6 over 5 minus 1 is going to be negative 11 over 5. So substituting here is negative 6 over 5 is negative 36 over 5 plus 25. Negative 36 plus 5. So this is negative 11 over 5. So which means that this quantity and this quantity are the same, in as much as x is equal to negative 6 over 5. Next, how about y? If y is replaced by 1, no, negative 1, so we will have negative 3 plus 1, which is exactly equal to 1, and I have a good answer. Now let's check this quantity. So this question is okay, is checked. This is also checked. How about this? Okay, this is negative 6 over 5 plus 4 times z equal 11 over 20, which means we have negative 6 over 5. We add 4 times 11 over 20. So this is gonna be equal to, after simplification, is equal to 11 plus 11 over 5, which is 5, 5 over 5, which is 1. So this quantity is equal to 1, and here, this is also verified. Okay, so the first and the second questions are answered. So we move to the next question. Let us move to next question number 3. Question number 3. Very quickly, because seems like we are running out of time. Since okay, this has been done very quickly anyway. Okay, now next, let us move to question number 3. Okay, so about number 3. Okay, this is running out. ink. So number 3 is we have to perform. Oh, so I don't have enough ink here. So let me check this if it works. Okay, so A is 3 times negative 2, 1, 3, 2. So minus twice 1, 4, and negative 1, negative 1. Okay, that is it. So we have to perform each of the following operations. Binary operation on matrix. Okay, now here we have B is equal to a 2 by 3 matrix, 1, 8, 1, 3, 1, 2, 4, negative 1, times, this is a product, 1, 3, 1, negative 1, negative 1, 2. Okay, so now this is number 3, so question A and B. Let us also use 4, question 4, invertible 2 by 2 matrices A, B, and X. These are invertible matrices are such that 4A minus 5B times X is equal to B. Now A make X the subject of the formula. So we can try to find a formula to find X, and B find X if matrix X if A is twice matrix A. Okay, so let us now answer these 4 questions. I mean these 2 questions. So now here we have matrix number 3, A, this question. So we have to make operation. So, okay, it is subtraction. Okay, subtraction of 2 matrices. The first matrix is okay. For this scalar multiplication, we multiply each one. So negative 6 times 3 is 3 times 3 is 9. Then 3 times 6. So this one 2. Now 2 times each coefficient. We have 2. We have 8. We have negative 1. Then according to what is written here, is let me check. Correct. Negative 2 times negative 2 is negative 2. Then negative 2 again. So we make a subtraction and find this will be a 2 by 2 matrix also. This element negative 60 minus 2 negative 8. This element 3 plus 2 5. This element 9 minus 8 1. This element 6 minus plus 2 6 plus 2 is 8. So now result is this matrix. Okay, now second question. Okay, this question will let us find. So we can save this answer for sub-question A as answer. We can save it here as a result. It is negative 8 5 1 8. So I preserve this answer in order to check after the video is uploaded to see if it's correct or not. Because when we calculate like this, sometimes it is very simple to be mistaken here. Okay, now let us find this matrix. So as this matrix is a 2 by 3, this one being a 3 by 2, so the result will be a 2 by 2 matrix. 2 by 2 matrix. 2 by 2. Okay. Let us try to calculate this one. So now, how to find? Let us calculate it over here. So as it is a 2 by 2 matrix, we can find this element to be equal to -1 plus 3. Now that to find this, and then -1, this -1 plus 3 minus 1. Then this element, you have -3, then -3, then 1, so plus 2, 1 times 2, 1 times 2, yes, it is 2 here. And then we look for this element, 2 plus 4 plus 1, 2 plus 4 plus 1, this is the result, 2 plus 4 plus 1, and then this point, 6 minus 4, 6 minus 4, 6 minus 4, then minus 2. This is the matrix, and it is equal to results 1, 3 minus 1, -6 plus 2 is -4, and then this is gonna be 7, then 6 minus 6 is going to be equal to 0. Okay, so we have come to the end of question number 3. So now let us look at this interesting question where matrix this matrix A, B, and X are invertible. It is like for multiplication, it is like for numbers by respecting matrix multiplication. This will bring us to the conclusion that 4A, if I bring B back here, then minus 4B minus B. So it's going to be this term on the other side, 5BX. So that is the result according to addition of matrices. Now we can add negative both sides, then positive B5BX. Next, what can we do? We can multiply both sides by inverse of 5B times the first side, negative B. This is equal to, actually we are looking for values of X as a function of the constant matrix like A and B, for example. Then we have to multiply by inverse on both sides. So by making so, we have value of X. Now, the inverse of a matrix is such that the inverse of a product of a matrix is the product of inverse in reverse order, which means that if we have suppose matrix A times the matrix B, so we can multiply, but they have same order, so inverse, because they are invertible. So inverse, the rule is that it is the product of inverse of this matrix in reverse order, which means this is the rule for inverse of matrix of product of matrices. So in this case, This is the rule. So this rule we can write it here. Inverse of this matrix is product of their inverses in reverse order, like inverse of B times A. Inverse is inverse of A times inverse of B, reverse order also. Okay, that is the formula, and then we can have inverse of B times inverse of 5. So times 4 times A minus B equal to X. And then this is like negative 5 power negative 1 is 1 over 5 times B inverse 4A minus B equal to X. So now here we can multiply inverse inside, and we have 4 can inverse, then B minus 1 power minus 1 times A minus B times inverse times B. So all of this is equal to X. So here this is a scalar. A scalar can is commute with any matrix, so there is no problem to have this one according to matrix multiplication. Okay, now next we have result will be X is equal to 1 over 5. Now 4 B minus times A inverse of B. Now minus product of matrix and itself is equal to identity matrix. That is value of X um, if it was properly multiplied. But here I forgot. I still have 1 over 5 outside. No problem. Nothing forgotten. And then now we must have, now that was the sub question A. Now let us move to sub question B. If A is equal to twice, no, this is not A equal to twice A, it can't be. But if A is equal to twice B, that is the twice B. So what will be X? So X is 1 over 5. Whenever we have A, we substitute by twice B is equal to 4 times inverse of B times A twice A and A twice B. A is twice B minus the identity matrix of the same order like this matrix, that is X, which is actually equal to 1 over 5 times Z. Then here scalar commute is 8 times Z. B times inverse is identity matrix minus identity matrix. So which is the difference is 7. Then you have 7 over 5 times identity matrix. So in other words, X is a scalar matrix, identity matrix, depending on the size of matrix A, B, or X, or actually depending on the size of matrix A and B, because you can see this has the same size, and if B equal to it means that B and X and A are square matrices. So in this case, we have the answer for question 4. Okay. Now we are left with question 5. Okay, so now let us calculate quickly question 5. We have a total of 10 questions, so we are going to stop at question 5 and In another video, we are going to look for other questions. For the moment being, let us work on question 5. And then later on, we're going to be working on other questions, other 5 questions. What about question 5? Question 5, question number 5. Okay, so here I'm running out of markers, so let me count. Okay, so here let us work out question number 5. We're going to use different markers here. So marker pen, let me use this black one. I hope it is working. It is working. Okay. So now here, let us work number 5. So question A, given H is equal to 201, then 300, then 511, and B is equal to 101, 121, and 111, 110. Okay. Now, question is, what is A times B? What is the product? And double I, what is B times A? Okay. Probably we can conclude whether this can show that in some cases, if they are different, conclude that matrix multiplication is not commutative. So in this case, we can have B. We have also B. B. We have to calculate the product of the two matrices. 1 minus 3. So matrix H, the first. Matrix negative 1, 2, 1, 1, negative 1, 0. Matrix B is 1, 2, 3, 2, 4, 6, 0, 2, 3. And the question is, what is the product A times B? So here is the question of matrix multiplication. Okay, so now answer. Let us answer to this question. H, we find A times B. So question I. So this is a 3 by 3, a 3 by 3. So the answer will also be a 3 by 3 matrix. So what is the first element here? Negative 1, no, positive 1, negative 2, it is negative 1. So this one, 2, negative 4, it is negative 2, plus 2, 0. So 3 minus 6 is negative 3, plus 3 is 0. Okay, so so the checking negative 1, negative 0, then 0, 2. Okay, now second row, product is negative 3 plus 4 is 1, negative 3 plus 4 is 1, and then second element, negative 6 plus 8 is 2, minus 2. So 80 minus 6 is 2, 2 minus 2 is 0. Then next, the third element, negative 9 plus 12 is 3. 3 minus 3 is 0. Okay, this row, this element, negative 2 plus 2 is 0, and then this element is 0, 2, then this is 6 minus 6 is 0. So this is the product of matrix A and B. Okay, so this is the product. Second one is B times A. So this is also a 3 by 3 matrix. So first element, it is Z. We take this one, multiply by this, get this times this is 1 minus 6 minus 6, 1 minus 6 minus 6 is minus 12, minus 11. Okay, this times this, 1 minus 6 minus 6 is minus 11. Okay, this times this, get negative 1 plus 4, negative 1 plus 4 plus 3, negative this one times this. Where am I? I'm still, no, this is not correct. What did I calculate? No, that is wrong. That is for question E, sub question B. I started by this product, so okay, that is sub question B. Okay, so it means that this is equal to 1 negative 1 1 3 minus so negative 3 2 negative 1 negative 2 1 0. So times this was 1 2 3 2 4 6 0 2 3. This was the product, and it was the only question because B, we are asked to find the product is this matrix. So it is this matrix. Okay. So now let us work out A. So A, this is A. Now for okay, for the, of course, for now A. Now A, we have A times B. This is a 3 by 3 matrix. So this, which is um, this matrix times this is going to be equal to 3. This one times this is going to be equal to 1. This times this matrix, this row times this column is going to be equal to 2. Product, secondly, see, this product and this product is 0. This one is 3. Okay. Now, this matrix and this matrix is 7. This matrix, this row and this column, it is equal to 3. And this one, this are going to be equal to 6. Okay. So that is A times B for this matrix. Now, this I, double I, so B times A is equal to 1, 0, 1, 1, 2, 1, 1, 1, 0 times 2, 0, 2, 0, 1, 3, 0, 0, 5, 1, 1. So what is it? It is 3 by 3 matrix. Okay, because 3 times 3, 3 by 3 times 3 by 3 matrix is also 3 by 3 matrix. And then let us look at how we find the result. This is 7, 2 times 5, 1. This is 2. Okay, now this is 6 plus 7, 13. Hmm? 7 plus 6, 13. And 1 and 2. So this is 5, this is 0, then this is 0, then this is matrix. Let me check. Okay, this and this is going to be equal to 1. So 1, 0, and 0 is 1. Okay, so now this being A times B, A here and B here, so is equal to this matrix product, and looking at to this matrix B times A in reverse order, this being B, this being A, the product is equal to this. So we see that, of course, we can conclude, we give some conclusion. A is not always equal to the product of A and B in reverse order, which means that in general, it means that matrix for multiplication is not commutative. So this brings us to the end of this video. In another video, we're going also to answer from 6 to maybe to 10 to the last question. We will see because these are preliminary exercises for students. They know how to do this one, so I prepare this video for them to review if they know how to do some operation, especially binary operation. So in the other exercises, in the following exercises, we also have other operations which are not binary. Okay, in exercise number, let me check. It was about finding x. It was the question number 4. We have a unary operation which is matrix inversion. It is not binary operation. This is unary operation, unary matrix operation, which means it is applied to, in general, it is applied to one matrix. Since the product of matrix is another matrix, it can be applied even to more than one matrix, but as a matrix, as a one matrix. So it is applied to one matrix. So with this, we have come to the end of this video. Thank you very much for watching. Next time.